1-5, adding and subtracting real numbers. So this lesson and the next lesson, we're probably going to go a little bit faster through these. Might not even have to watch these whole videos because hopefully you know how to add and subtract real numbers. But we do want to see exactly how these addition properties and in this lesson and the multiplication properties in the next lesson are actually working to give us a deeper understanding about how numbers work. Okay, so in this section, we're going to find sums and differences of real numbers. So our essential understanding is that we can add or subtract any real numbers using a number line model, or we can add or subtract real numbers using the rules involving absolute value. So let's look at the number line model first. Probably a pretty simplified model, okay? And the way addition is actually working is we are going to start with the first number and then add numbers to it. And the way that I add a positive number is I start at 3 and I move right on the number line 1, 2, 3, 4, 5 places to give me 8. And you're probably thinking, well, why didn't I just say 3 plus 5 is equal to 8? Because it is, but we want to understand exactly why and exactly how it is working. So if we look at number B, if we look at part B, we see we start at 3 again, but in this case, we go -5. So we go 5 to the left. 1, 2, 3, 4, 5, which give me an answer of -2. For C, we're going to start at -3 and move 5 to the right. 1, 2, 3, 4, 5 to give me an answer of 2. And in the last one, we start at -3. Okay, and now we go 5 to the left. 1, 2, 3, 4, 5. And we get a -8. Okay, so in all of these cases, we're going to start at the first number and we're going to move right or left depending on whether we are adding a positive number or adding a negative number. And we'll see in a few minutes that this expression right here, 3 plus a -5, can also mean 3 minus 5. Okay, so we're going to lump subtraction into this in a little bit. Okay, so let's try this one. -8 plus 4. That means I'm going to start at -8 and go 1, 2, 3, 4 steps to give me that -8 plus 4 is a -4. Okay, so that's the number line method. Now let's try it with absolute value. Okay, so the absolute value of a number is its distance from 0 on a number line. Absolute value is always non-negative since distance is always non-negative. Okay, doesn't make any sense if you're measuring distance to say, oh, that house is -1 mile away. That doesn't make any sense. Okay, so when we're talking about distance, we're always talking about non-negative. We're always going to measure from the point we are to the point where we're going. So for an example, the absolute value of 4 is 4, and the absolute value of -4 is also 4. And we can write it using our absolute value symbols and say that the absolute value of 4 is 4 because it is 1 from 4. 1, 2, 3. It is 4 units away from 0, just like -4 is 4 units away from 0. And we can use this idea of absolute value when we find the sums of real numbers. This is another way to think about how addition actually works. Okay, so when we want to add numbers with the same sign using absolute values, we can add two numbers with the same sign by adding their absolute value, and the sum has the same sign as the addends, which means the things we're adding together. So in our first example, 3 plus 4, they're both positive, is going to equal 7. -3 plus -4, well, they're both negative, so I just add the 3 and the 4, and I make the answer negative. Okay, so -3 plus -4 is going to be -7. When we add numbers with different signs, okay, we're going to subtract their absolute value. And the sum has the same sign as the greater absolute value addend. Okay, so that means we have to look and see which one is bigger, which one has a larger absolute value. So in my first example, -3 plus 4, if I were to subtract those, I would get 1, okay? And that one has a larger absolute value, so that is going to be positive. In the second example, a negative sign has the larger absolute value, which is why my sum is negative, okay? And yes, you could just say, well, I kind of know that already. I know that 3 plus negative 4 is negative 1, okay? But again, we're trying to get a good idea about how numbers are working in relation to each other. Okay, so let's add these real numbers by thinking about absolute value. Okay, these two, different signs. When I add them together, or sorry, I'm going to subtract them. So 12 minus 7 is 5. But my answer is going to have the same sign as the one with the bigger absolute value, so it's going to be negative 5. Those two have the same sign, so all I have to do is add them together to get 20, and then because they're both negative, my answer is going to be negative as well. Okay? Doesn't have to be any different with decimals. Okay? So now we are just going to subtract, and the answer is going to be positive because 9.5 is positive. So 9.5 minus 4.8 is going to be, oops, is going to be 4.7. Okay? Now, fractions. Don't forget how fractions actually work, and that if we want to add two fractions together, the first thing I have to do is find the least common denominator. So when I look at these two, okay, my least common denominator of 4 and 6 is going to be 12. Okay, which means I have to multiply the numerator of my first fraction by 3 to give me 9. And I have to multiply the numerator of my second fraction by 2 to give me 10. Okay. Now I can clearly see that 10 over 12 is bigger than 9 over 12, even though I wasn't quite sure about these two, which one was bigger. I kind of thought it was 5 over 6, but now I'm sure. So 9 over 12 is bigger than 10 over 12. So that means I'm going to subtract these two opposite signs, and my answer is going to be negative to give me a negative 1/12. Let's try our got it problem. Oops. Okay. Let's try the got it problem down here. Okay. So when we do these, right, my first one is 16 minus, or sorry, negative 16 minus an 8. And when we subtract those, they both have the same sign. So that's going to be a negative 24. I can add them together and keep the sign. Look carefully at B and C. Okay, they sort of represent a property that we might have been familiar with because the things are reversed. Kind of looks a little bit like the commutative property. And we'll see, and it is actually a representation of the commutative property, and we'll see that a little bit later. So in this first one, B, right here, we have negative 11 plus 9, which means that I'm going to subtract them, and the sign is going to be negative, so this is going to be a negative 2. As is that one, also a negative 2. And notice that they are both equal, which is a good sign if we're going to use the commutative property. And the last expression, negative 6 plus a negative 2, is going to be a negative 8, because they both have the same signs. All we have to do is add them. Okay? So, two numbers that are the same distance from 0 on a number line, but that lie in opposite directions are called opposites. Makes sense. They're in opposite directions. So in this case, 3 and negative 3 are both 3 units away from 0, so they are opposites. Okay? Usually opposites have the same numbers, different signs. And a number and its opposite are called something special. They're called additive inverses. Okay? So to find the sum of a number and its opposite, we can use the inverse property of addition, which says that for every real number a, there's an additive inverse, negative a, such that a plus negative a is equal to negative a plus a is equal to 0. Doesn't matter which order I do it in. Okay? there's always two opposites that if I add them together, I'm going to get 0. So for my example, we have 14 plus a negative 14, that's 0. They're opposites. One is a plus 14, one is a minus 14. Same thing over here. One's a negative 14, one's a positive 14. When I add these two things together, I get 0. So why do we care? Well, we can use these opposites, these inverses, to subtract real numbers. Okay, this is just another way to think about subtraction. And in fact, with our number system, okay, subtraction really is just addition. It's just a way to add two numbers. Okay, so let's look at that. So look at the number line below, which models 3 minus negative 5. We're going to start at 3, and we're going to go 1, 2, 3, 4, 5 backwards. Okay. Well, how is that any different than the second one right here, which starts at 3 and moves to the left? 1, 2, 3, 4, 5 as well. So 3 minus 5 and 3 plus negative 5 are equivalent expressions, which is very helpful for me because now when I want to subtract two numbers, all I have to do is add its opposite. And since now we're using addition, all of my other properties, okay, that we'll see again in a second, all of my other properties will still hold because we're using addition. So a minus b is the same thing as a plus negative b. Okay? And this is going to come important when we try to prove the commutative property for subtraction. So my example says that if I want to take 3 minus 5, I'm really doing 3 plus a negative 5 to give me negative 2. And when I do 3 minus a negative 5, right, when I want to add two numbers, or sorry, when I want to subtract two numbers, I add the opposite. So the opposite of negative 5 becomes positive 5. Okay? And so when we say that when we have a negative and a negative, okay, and we want to cancel those out and change the signs, we can do that. And the reason why we can do that is this property right here, the property of the opposite, or the, what do you call it, the inverse property of addition. Okay, so let's see how this works with some problems. So what is each difference? Negative 8 minus negative 13. So in this case, I can say that because I'm subtracting, I want to add the opposite of negative 13, which is a positive 13. And now I realize that the signs are different. So when I add them, when I want to add two things with different sides, I subtract them and keep the biggest sign, which is positive. So my answer is a positive 5. Okay. Same with decimals. Okay. Doesn't matter that we have decimals. We're still going to use the same idea, 3.5 plus and negative 12.4. Okay. So the opposite of 12.4, right? We're going to add the opposite. The opposite of 12.4 is a negative 12.4. Okay? And when I add these, we get a negative 8.9 since the negative 12 is bigger than the positive 3.5. The last one, 9 minus 9, well, I know it's 0, but let's look at this. We're going to do 9 plus the opposite of 9, which is negative 9, which gives me 0. And I can see that those are additive inverses of each other because they add to 0. Okay. Let's look at our got it problem. Okay. So for our got it problem, we're going to do another decimal. We're going to go 4.8 minus a negative 8.7. Okay. So when I do that, I'm going to do 4.8 plus the opposite of negative 8.7, which is a positive 8.7, which gives me 13.5. This one is interesting. Okay. So for what values of a and b does a minus b equal b minus a? Well, we know that this is true, that the commutative property of addition is true, that a plus b is equal to b plus a. So you would think that because addition and subtraction are so closely related that this would be true. But it's clearly not. Because if I plug in some numbers, let's say a is equal to 2 and b is equal to, keep it easy, 3, that would say that 2 minus 3 is equal to 3 minus 2. But 2 minus 3, the signs there is going to be negative, is not equal to 3 minus 2. So negative 1 is not equal to 1. But if I think about this more in terms of how we have talked about addition and subtraction, I can rewrite this as 2 plus a negative 3 equals to 3 plus a negative 2. And I can see that that is clearly different. So if I want the commutative property to be true with subtraction with negative signs, I have to make sure that the stuff that I'm writing on both sides of the equation are the same. So if I want to say 2 plus a negative 3, I had better keep this number the same, like negative 3 plus 2. Which means if I go back to my equations right here, this one is not going to be true, but we can see that a minus b is going to be equal to negative b plus a, as long as I keep the sign in front of b the same. Okay. Another way to look at it would be a plus a negative b is going to be equal to negative b plus a. As long as this term is always the same, then my property of real numbers will work. Okay? So all of my addition properties of real numbers apply for both positive and negative, provided that we hold the signs the same. So the two major properties we talked about in the last lesson were the commutative and associative, and we just saw that the commutative property can work with negative numbers, provided I keep the signs the same. And the same thing with the associative properties. As long as the signs of these terms do not change, then these properties will still work with addition or subtraction. Let's wrap it up with a word problem. Problem 4, adding and subtracting real numbers. Scuba diving problem. A reef explorer dives 25 feet to photograph brain coral, then rises 16 feet to travel over a ridge before diving 47 to survey the base of a reef, and then rising 29 feet to see an underwater cavern. So what is the location of this cavern in relation to sea level? Well, we're starting at 0. That's our sea level. And we're going to dive down. So that's going to be minus 25. We're going to go down. Then we're going to go back up 16 feet. Then we're going to go back down 47 feet. And then we're going to go back up 29 feet. Okay. So if I wanted to, I could just go straight across. I can use what I've learned, that I can add a negative 25, I can add a 16, I can add a negative 47, and I can add a 29. Okay, I can use some properties if I want to keep the positive numbers together and the negative numbers together. I can use my properties of addition. So I can get rid of 0 because adding 0 to something does not do anything. And I can take my two positive numbers, 16 plus the 29, and do those first. And then I could add the negative 25. Oops. The negative 25 and the negative 47 later to give me 45 with these two plus a negative 72, and altogether gives me a negative 27. Always include your units, so there's going to be a negative 27 feet. Now, of course, we could just go 0 minus 25 plus 16 minus 47 plus 29, either in our head or on a calculator to give me negative 27. Okay? The point is to understand a little bit how these interactions with these numbers are actually working. especially with the different properties. Same sort of problem here. Rope Out Submarine. We're going to start at 0. It's going to dive 803 feet. It's going to rise 215 feet. The submarine then dives nice and deep, 2619, into a deep crevice. Next, it rises plus 734 to photograph a crack in the wall of the crevice. Okay? So what's the location of the crack in relation to sea level? Sea level. So there's where I started. There's where I ended up. Okay. For this one, I am going to use my calculator and just go negative 803 plus 215 minus 21, 26, 19, and then plus 734 to give me a total of negative 2473 feet. Hopefully I didn't make a mistake there. Okay. So let's check, make sure that we know how to use a number line to add numbers, to find the sum or difference, okay, when the signs are the same or when they're different. Vocabulary, what's the sum of a number and its opposite? Those are additive inverses. How is subtraction related to addition? Subtraction and addition are the same operation. Okay? The only thing that's different is subtracting is when you add a negative number. Okay? Which is why all of our properties can work if we keep the signs, if we keep a conservation of signs. Number 9, however, says your friend says that since negative a is always the opposite of a, the opposite of a number is always negative. The error with this is that what happens if I start at negative 9? Well, then the opposite of that number is still negative a. It's just negative 9. Ooh, that's supposed to be a 9, which is then a positive 9. And that's true because if I bring this down here, negative 9 plus positive 9 is 0, which means that they are opposites of each other. Okay? And that was 1-5, adding and subtracting real numbers.